to Chemtech Laboratory Tutorial. Today we'll be looking at Dalton's law of partial pressure. Dalton's law of partial pressure states that the sum of the individual gases present in a container is equal to the total amount of gas pressure that is exerted on that container. So therefore it means PT will be equal to P1 plus P2 plus P3 down to P infinity. If we have three gases in the container, each of the gas excites a pressure, and the sum of the pressure exerted by each of the gas will give us PT. So the gases can be to infinity. It therefore means that we will now introduce our ideal gas equation, which is PV equals to nRT. So the total pressure of the gas excited will be nRT over V for 1 mole of each of the gas. So for each gases, if it's P1 will be N1 RT over V, and P2 will also be N2 RT over V, and P3 will also be N3 RT over V. Therefore, the sum of the number of moles of each of the gases will now be NT is equals to N1 plus N2 plus N3. So therefore, the total pressure will now be PT equals to N1 RT over V plus N2 RT over V to N infinity RT over V. So PT will therefore be N total bracket RT over V. So at a constant volume, constant temperature and molar gas constant, our PT will be equals to NT times R times T all over what? V. So it means that we can get our partial pressure, our total partial pressure from number of moles, and we can also get individual partial pressure from what? Our total pressure. How do we do that? It means that we will take a ratio of an initial or one particular gas, which is N1 RT over V, of PT all over NT RT over V. These are like terms, so therefore it will cancel. So we will be left with P1 PT equals to N1 all over NT. Therefore our partial pressure for a particular gas will be equals to N1 all over NT times what? Times PT by the time you cross multiply. The mole ratio will therefore be N1 all over NT. So we use X to represent mole ratio of the partial pressure of one gas. So it will be N1 X1 equals to N1 all over NT. If it is mole ratio of 2, it will be N2 all over NT. From our equation of partial pressure equals to N1 all over NT times PT will therefore be partial pressure equals to mole ratio 1 PT. So this will now be the formula for partial pressure when the mole ratio is being given to you. So we are going to take one example, which is the pressure on the surface of Titan is 1,220 tons, and the atmosphere consists of 82 mole of nitrogen gas, 12 mole of argon, 6 moles of methane gas. Calculate the partial pressure of each gas. And remember, we proved that partial pressure is equals to the mole ratio times the total number of pressure exerted on this surface. Then it means that our X1 will be equals to N1 all over NT. the first step is to calculate for your mole ratio so that you can get the partial pressure of each of the gas. So let's assume our P1 is nitrogen, and they said 82% of what? Nitrogen. That means 82 x nitrogen gas is equals to 82% all over. If you add 82 plus 12 plus 6, it will give us what? 100%. So the total number of moles of all the gases present is equals to 100, and for nitrogen gas we have 82. So it therefore means that we will have it as N2 is equals to percentage, we cancel percentage, and we are left with 0.82 mole ratio. So, and we know that mole ratio does not have a unit, so it will be 0.82. That means the partial pressure will therefore be equals to 0.82 times the total pressure of the surface of the tank, which is 1220 ton. So P nitrogen gas will be equal to 1000.4. So it will be in ton, because the unit of total pressure was given in ton. So your partial pressure of nitrogen gas will be what? 1000.4 ton. Okay, so we calculate that of argon. That of argon will be the same formula, which is partial pressure of argon is equals to mole ratio of argon times the total pressure. What is the mole ratio of argon? You use the same formula that says N argon all over what? N total. So we know that the total is 100% and N argon is 12, so it will be 12% all over what? 100%. So percentage cancel percentage, and the mole ratio of argon is 0.12. So it means the partial pressure of argon will be equal to 0.12 times 1220 ton, which will now be equal to what? It will now be equal to 146.4 ton. So that is that for argon. So let's do that of methane gas, which is the partial pressure now for methane. Let's calculate that of methane. So that of methane will be CH4, partial pressure of methane, times the mole ratio of methane by the total pressure. And this will now be partial pressure of methane is equal to, you are going to use the same formula, which is N methane all over N total. That is total of all the gases times the total pressure. And what is the value for N methane? It is 6 moles. So it will be 6 divided by 100 times what? 1220 ton. So you see your partial pressure of methane will be equal to 73.2 ton. So means the partial pressure of methane is equal to 73.2 ton. Thank you, and keep watching ChemTech laboratory tutorial. Please don't forget to like, share and comment.
Please make sure to do your assignment. And don't forget to share, subscribe, like and comment.